In the final part of the experiment, we're going to be looking at the acceleration due to gravity, g. So we're going to try and calculate that. And the way we're going to do that is by inclining the air track at 4 different inclinations and looking at the motion of the cart. So first of all, we have to make some definitions in our track. We need to measure the distance L, little l, from your notes. That's between the 2 ends of the feet, so the front feet and the back feet. You need to measure that and record that in your notes, little l. You also need to measure the distance L between the photo gates. That's going to give you your length measurement in the equation on page 12 of your notes. Now, what we're going to do then, we need to know very accurately what our angle of the track is. So we're going to have to use this little l, which is the distance between the feet, and also the height of the foot from the table. So we're going to be varying that using blocks of wood. So for the first inclination, we'll take 1 block of wood, pop it under the front foot like this, and that's our first inclination. So we need to know the thickness of this. And then as we go through the experiment, we'll take the motion of the cart there, and then we'll take it with 2 wooden blocks, 3, and 4. That will give us 4 different angles. So to measure the thickness of the blocks, we're going to use the micrometer. And you would have learned to use that in the first experiment. That will give us quite an accurate measurement of the thickness of these. So then we have an accurate measurement of the angle, and we can start taking our data. So first of all, we're going to take 1, pop it under there, put your cart on the track, start the collect button, and just let it accelerate due to gravity. And stop. So from your data, you'll be able to subtract the first on state that happens from your picket fence, subtract that from the second one, and you should have the time that it's transited from here to here. So you'll have the length from here to here, you'll have the time, and you'll have the angles. Now if you look at your notes on page 12, there's an equation that says 2L on t squared equals g sine theta. Now that doesn't look like a linear equation. You've got a t squared there, you've got a sine theta, so it's not linear. So we can do some manipulation with some graphing here to turn it into a linear equation. And it's called linearizing an equation. So you might remember from high school the equation for a straight line, y equals mx plus c, where y is on the y side of your graph, x is the x-axis, m is the gradient of a line, straight line, and c is the y-intercept. So if we look at this equation, 2L on t squared equals g sine theta, if we put 2L on t squared on the y-axis, and we put sine theta on the x-axis, we now have a linear equation with a gradient of g and a y-intercept of 0. So we take all of our data points now that we have, so we have a few different measurements of theta that we had by varying this angle, and we have different measurements of t, the time to traverse from here to here. So if we do that graph of 2L on t squared equals g sine theta against g sine theta, then we will get a gradient of g. So you need to take your data, do that graph, find the slope of that straight line that you will draw, and you have g with uncertainty.